Welcome to Hartman Math. This is lesson 2.4, where we're going to solve some quadratic equations by factoring, a little bit of a review of some previous content, a little extra skills, such as we know if we're solving by factoring, we're going to want to use the zero product property, which means one side of our equation needs to be zero. So we need to make that happen in this equation. Now it's tempting, because it would be fastest, to make the left side equal to 0. But our second issue is the x squared. It's going to be far easier for us if it's positive. So since this one's negative on the right, I think we should move everything to the left side, get the right side to be 0, so we don't have negative x squareds. So we'll go to the left. So we're going to add a 7x squared to both sides, and then to get rid of the 6, we're going to subtract 6 on both sides. Make sure when we do that, we put it in the correct order. ax squared plus bx plus c. So x squareds, then x's, then constant. Make sure we don't lose the equal sign, equals 0. So we want to get one side equal to 0. We really like the x squared term to be positive. It makes the factoring a lot easier. So as we go through our factoring process, we want to think GCF first. This is our greatest common factor. That needs to be first thought always. And there isn't anything in common, so we're going to factor into two sets of binomials, two sets of parentheses, looking at 7x squared first. How do we create that? 7x times 1x. Now, as far as the negative 6, what are our pairs of factors for negative 6? Always start with 1. So 1 and negative 6. 2 and negative 3, and then obviously sign issues, but that can be fixed later. So if we pick a pair and try, and they are different in the front, so if we try 1 and 6 and it doesn't work, you can reverse it. So if you want to pause here, see if you can figure out which one it's going to be. And if you end up checking by going outside, inside, and you get negative 11x, it means keep them where they are, but just change the signs. I think the one that's going to work is if this is a minus 3, this is a plus 2, because outside would be plus 14x, inside is negative 3x, and those combine to be positive 11x, so we're there. Once we get it factored, we know we're supposed to split it because of the zero product property. First factor equals 0, second factor equals 0. 7x minus 3 equals 0, x plus 2 equals 0. Solve, solve. So we're going to add 3 to both sides. We're going to divide by 7 on both sides. Subtract 2 on both sides. Box our pair of solutions. A lot of these quadratic equations are going to have 2 solutions, although that's not a guarantee. They can't have any more than 2. All right, your turn. Pause here. Go ahead and work through. Hit play when you're ready to check. So another one where we got to get it equal to 0. X squared is positive on the left. Great, let's keep it there, which means let's get rid of the 20. Let's subtract 20 on both sides. Keep in mind the plus x does mean plus 1x, so that when we go ahead and factor, we go x and x, and we list the factors of negative 20, such as 1 and negative 20, 2 and negative 10, 4 and negative 5. And as we try to figure out which one works, this one gets us close, but I think we're going to need to switch the signs. We get a positive 5 and a negative 4. If we had tried these, we would have got negative 1x. So we just switched the signs. Split them. Set them equal to 0. Solve, solve. Our 2 solutions, x equals negative 5 as we subtract 5 both sides. Add 4 to both sides, x equals 4. Example number 2, 3x squared equals 39x. We want to solve this by factoring. We want to get one side equal to 0. Again, liking that the left side has a positive 3x squared, so let's leave that there. Let's get rid of the 39x minus 39x on both sides. Don't forget about your equal sign. Don't forget that it needs to equal 0. Now we can factor that. Step 1, always GCF. Is our greatest common factor? Well, both terms do have a 3. Both terms do have an x, so we'll factor out a 3x. 3x times what makes 3x squared? It needs an x. Minus 3x times what makes 39x? That would be minus 13. Split 3x equals 0. X minus 13 equals 0. Divide by 3. 0 divided by 3 is still 0. Add 13. And those are our solutions. Example 3 looks pretty similar. It's just a little bit different. But we do want to get it one side equal to 0. Like in the 9x squared, we're going to have to get rid of the 25. We're going to subtract 25. There is no GCF. This one doesn't have an x. There's no number besides 1 that goes into 9 and 25. So there's no GCF. There's only 2 terms. So our standard, let's set up those 2 sets of parentheses and go that. That process may not necessarily work. We need to recognize this is a special binomial with 2 terms. And it's called a difference because it's subtraction. It has to be difference, it has to be subtraction. Difference of 2 squares. The difference of 2 squares factoring pattern is if the first thing is a square, I think this is, and the second thing, 25, is a square, and it's a minus, it can factor into, and it does look like our 2 sets of parentheses. But it is a little bit special because the fronts have to be identical. It could not be like a 5x and a 2x. They have to be exactly the same. The backs have to be exactly the same. We couldn't have a +7 and a -2. They have to be the same. One side's a plus, one side's a minus, and it doesn't really matter which is which. So as we set this up, yes, this is a difference of squares. So with our 2 sets of parentheses, what is being squared to get 9x squared? We need the 3 to make the 9. And for as far as the x squared, what are we squaring to get x squared? X. So essentially the a that goes here and there is 3x. Because if we square 3x, multiply it by itself, that's what we get. And then what about the 25? What would we square to get 25? 5 and 5. One's a plus, one's a minus, and it doesn't matter which one's which. All right, split, set them both equal to 0. 3x plus 5 equals 0. 3x minus 5 equals 0. Subtract 5 both sides. Add 5 both sides. Divide by 3 on both sides. Divide by 3 on both sides. X is -5/3, and x is +5/3. That's the difference of squares. So we're looking for that when it's 2 terms, has to be a minus. First thing is something squared. So if that number is a 7, this doesn't really work. We're looking for squares. Like 1, but you probably wouldn't see it. So if it just says x squared, that would probably fit. 4x squared. 36x squared. 81x squared. All those perfect squares. Same thing back here with the constant, the number by itself. That needs to be a square. We're going to wrap up with a your turn, so go ahead and pause here until you have it worked out. It's already equal to 0. That means we're ready to factor. There's no GCF. There's 2 terms. I wonder if it's a difference of squares. It's a difference. That's a square. And yeah, 49 is a square. So as we split it up, what would we square to get x squared? X. So x goes in the front. What gets squared to make 49? 7. That goes in the back. One's a plus, one's a minus. split them, set them equal to 0. We solve from there. That's it for today. I'll see you next time.